Okay, let's take a look at example 1. We worked example 2 out in class, so we'll focus on this first one. So we have a little block on an inclined plane and another one, block B, being hoisted up by some pulleys. And let's see, so we're told that the mass of block A is 10 kilograms, mass of block B is 3 kilograms, and if block A is moving down the inclined plane with a initial velocity of 2 meters per second, we're asked to determine the velocity of B when t equals 2 seconds. And we're to assume the inclined plane is smooth and to neglect the mass of the pulleys and cord. Okay, so this one is a clear example of a impulse momentum type problem. So maybe the first thing we'd like to do is draw a free body diagram, which I'll go ahead and do. So we have the block, and there's going to be a tension acting on it, call it T. There's normal force, no friction. This angle is 30 degrees, like this. And we have gravity acting on it, so its weight is going down. That's mg. And so this is block A. If we go and look over at B, we have the tension pulling up, but there are two of them, so this is actually going to be 2T. And we have, let's see, the mg over in the first case was mag, and this is going to be mbg. So that's our free body diagram. Now maybe we want to establish our coordinates. And looking at the original drawing, I'm going to let this displacement be SA, going downhill like that. And I'm going to let this be SB, also going down. And we know that this is VB because we're told it's going to be pulled up. Well, or we should assume that anyway, because the inclined plane is being 10 pounds, and the amount of gravity force on that would be proportional to the sine of the angle, which would be 30 degrees, and therefore 1/2. So if this is 10 kilograms, it's going to pull the 3 kilogram mass up even without the pulley. So let's take a look at what we need to do. And so I've got the coordinates established there, and I could either right now look at the kinematics, or I could go and write the impulse momentum formula. So let's just do the latter in this case. So looking at A, we have MA VA1, that's his initial velocity, times mass, that's his momentum, plus the integral, and we're told this is going to go 2 seconds. So 0 to 2 of all these forces, we have MAG acting on it, times sine 30. And I've kind of drawn that, assume that to be positive going downhill like that, minus the tension, dt, and that gives us the impulse, and that's going to be equal to MA VA2. So it's second state momentum. So that gives us one equation. And so if we go ahead and substitute, do the integration. We'll just get a 2 times the middle term in that equation. And if we do a bit of rearranging, well, let's just go ahead and write it out, substituting in the values. We're going to get 20 plus 10 times g, 98.1, minus, and then 2, which is 2 seconds times all of the middle term here. That's going to be, rather, times the t. That's the only one left, I guess. So there's the 20, and this would be the MAG times sine of 30, which is 1/2. And we wind up getting 98 well, actually what we get is the 2 cancels with the 1/2, and we're left with the 98.1. So this is going to still be then 2t, and that's going to be equal to still 10 kilograms times VA2. And when we substitute in more values, or actually do some algebra on it, we wind up getting 2t plus 10 VA2 equals 218.1. And of course this is going to be in newtons. So that gives us equation 1. Then, let's see, we want to look maybe at B. And for B, we have MB times SB1 dot plus integral up to 2 seconds of MBG's, the gravitational force, minus 2t dt. And that will all equal MB SB2 dot. I'm using the SB instead of VB because I've shown SB positive down, and when we finally substitute in VB, we're going to get a negative SB for that. And so that winds up being, let's see, I'm going to get MB SB1 dot plus 2 MBG minus 2t is equal to same thing, MB SB2 dot. Okay, I'll call that equation 2. And now we've gone about as far as we can go without applying kinematic constraints. So I'm going to continue to write down here. So that's the next thing. And what we wind up having is, well, we got one SB going down like that, and this is 2S, that's one SA, I mean. This is going to be 2 SBs. So we have SA plus 2 SB equals a const. And therefore, we can get SA dot plus 2 SB dot equals 0. And therefore, we know that SB dot is negative 1/2 of SA dot, or negative 1/2 of VA. Now, that implies that SB1 dot is equal to negative 1/2 of VA1, which was given as 2 meters per second. So this is equal to negative 1 meter per second. And so 2 becomes, well, let's see, what does 2 become? 2 becomes, let's see, that will be negative 3. That's 3 kilograms times negative 1 meter per second, plus 2 times 3 times 9.81 minus 4t. And that would be equal to MB, which is 3, SB2 dot. And we clean this up a bit. We wind up getting 3 SB2 dot plus 4 T is equal to 55.9. Again, this is going to be in newtons, I believe. Or, in fact, actually, it's going to be in Newton seconds, isn't it? I think I said the wrong thing there. Yeah, Newton seconds, right? Yeah. So this other Newton thing should be Newton seconds too. That's the problem when you when you substitute in value numbers for symbols, you get lost sometimes. And so the other thing, the last thing to recognize here is that, so I'll just say, but SB2 dot equals negative VA 1/2 VA2, and so that means that I can write 4t minus 3/2 VA2 equals that 55.9. So I guess this would be 3, and this would be 4. Now, if we solve 1 and 4, so solving 1 and 4, we'll find, with a bit of work, that T is equal to 17.1 newtons, and VA2 is equal to 8.39 meters per second. Therefore, the velocity of VB2 is 1/2 of that, which is equal to actually 4.19 meters per second. So that's the velocity of B, and it is going up as requested, and I think that's all we needed to find. So I hope this has been somewhat instructive, And thanks again for your patience and listening.